All right, guys, 5.3, we're solving trigonometric equations. You will be given the unit circle. You will be given your trig identities. What I need you to remember, and if you don't, write this down right now. If I have an ordered pair, right, I have an x value and a y value that is on the unit circle. And I ask you what these 6 trig functions are. What is the sine? The y value. The sine of theta is your y value. What is the cosine? Your x value. Perfect. What is the tangent? Y over x, right? Nothing new. So now I'm going to talk about the reciprocal functions. What's the reciprocal of sine? It's cosecant. What is that going to be? 1 over y. The reciprocal of cosine? 1 over x. And your cotangent is x over y. Is that new to anybody in this room? No. We're going to use that in addition to our unit circle, and we're going to solve equations. So if I look at this first equation, how do I tell you guys to think? Algebraically, right? So if this said to you, if I gave you this equation, 2x minus 1 equals 0, and I said solve this, you guys would laugh at me. Right? What would we do to both sides? Add 1, so 2x equals 1, and then what? Divide by 2, so x equals 1/2. You guys agree? The exact same thing, guys. Here is your equation. Here is your trig function that we want to isolate. We're going to isolate your trig function first by solving using our algebra skills, and then we're going to find out what the answer is. So in this case, what would I do? Okay, let's add 1 to both sides. Perfect. So I have 2 times the sine of x equals 1. Again, we're trying to get sine x by itself. So what do? Divide by 2. And you guys get here, the sine of x equals 1/2. Well, I'm not concerned about what the sine of x is. I want to know what the value of x is. I want to know what angle they're talking about. So this is where we go back up to this little chart up here. What is sine? Your y values, correct? So you're going to go to your unit circle that I'm going to give you. And you're going to find where all of the y values are positive 1/2. So go to your unit circle over here. Where are your y values positive 1/2? But what the actual angle is what? We want it in radians. So pi over 6 and there's your answers. That's it. So you would tell me x equals pi over 6 and 5 pi over 6. So you're going to solve the equation, find the answer on the unit circle, and write it down. It does not get much harder than that. I promise you. All right, let's look at the next one. Find all the solutions for. Now, look at this. It says over the interval of 0 to 2 pi. What that means is 1 trip around the unit circle. That's what all of your questions are going to say. On WebAssign, it doesn't say that because they're expecting you to answer with the, like you'd get this answer here, and then you would say pi over 6 plus 2k pi. Meaning, I could add 10 circles and get back to the same answer. I could subtract 10 circles. We're not doing that. We are worried about just 1 trip around the unit circle. So that's what that means. You have to do nothing with that. You don't even have to pay attention to it. Just understand that's what that means on the test. So if you have a question like this, again, let's think algebraically. If I had x plus the square root of 2 equals negative x, how would you guys solve this? You get the x's together, right? So I'm going to go ahead and just add x to both sides and subtract the square root of 2. You guys agree? So you have 2x equals negative square root of 2, and then what? Divide by 2, so x equals negative square root of 2 over 2. That's exactly what this question is saying. It's saying solve. When you solve, you get like terms together, yeah? So I have sine of x plus the square root of 2 equals negative sine of x. You can move anything to either side. It doesn't matter. If you want to move the one side on the right to the left, do that. You want to move the other way, I don't care. If I subtract the sine of x from both sides, I have the square root of 2 equals negative 2 sine of x, correct? You guys with me? How do I get sine of x by itself? I divide by -2. Perfect. So this is the sine of x equals negative square root of 2 over 2. That's not your answer. I want to know what angle that's representing. What is sine? Y values. So you're going to go to the unit circle and find all of the y values that are what? Negative square root of 2 over 2. So go over here. Where is my y value? Negative square root of 2 over 2. 5 pi over 4 and 7 pi over 4. Perfect. So we're going to say x equals 7 pi over 4 and 5 pi over 4. That's it. Questions? It's a lot easier than verifying, yeah? I'm going to come back to 4. Don't worry about 4. All right, same question. Same question. If I write 3x squared minus 1 equals 0, how do you solve that?
You bring 1 to the
Okay, add 1. Good. Now what? Divide by 3, so x squared equals 1/3. Now what?
square.
Take the square root, so x equals, what do I put in front of it? Plus minus 1 over the square root of 3, right? And then do we leave it like that?
No, you have to.
X would be plus minus. You'd rationalize, you get root 3 over 3. Yeah? You guys agree? Everybody understand? The square root of 1 is just 1, so we would just leave it. So guys, same thing here. I want to get the tangent squared by itself. So what would we do? We're going to add 1 to both sides. So I have 3 times tangent squared equals 1. Again, we want tangent squared by itself. So we're going to do what? Divide by 3. Perfect. So tan squared of x equals 1/3. Do we want tan squared or do we want tan? So take the square root. When you take the square root, what goes in front of your answer? What goes in front of your answer? Plus or minus. Guys, this is the square root of 1 over the square root of 3. What's the square root of 1? 1. Can you leave the square root of 3 in the bottom? No, you have to rationalize. This becomes square root of 3 over 3. That's not the answer I'm looking for. I want to know what angles have a tangent of positive or negative root 3 over 3. How many answers should I have here? 4. Because 2 of them have a positive tangent of that, and 2 of them have a negative. Now, where? Think about this. Tangent is when I take the y value and I put it over the x. What you guys need to understand is the unit circle is the same all the way around. Look at the ordered pairs. Look at the ordered pair at pi over 3, and look at the ordered pair at 2 pi over 3. What's the only thing that's different? The signs. Look at pi over 4 and 3 pi over 4. What's the difference? The signs. Look at 3 pi over 4, 5 pi over 4, 7 pi over 4. Guys, what's the only thing that's different about the ordered pair? All the over 4s. They're all root 2 over 2, right? Look at all the over 3s. Pi over 3, 2 pi over 3. They're all the same ordered pair. The thing that's different is the signs. So the only thing you really need to know is the first quadrant. And then you guys already know what the signs are of x and y in each other quadrant. So if I asked you right here the tangent of pi over 2. What's the tangent of pi over 2? Take the y value and put it over the x. What's the tangent? Undefined. So if it's undefined at pi over 2, what is it at 3 pi over 2? Undefined. Same thing. If I go over here at 0 or 3 or 2 pi, your tangent here is y over x, which is what? 0. So what's the tangent, guys, at pi? Take the y, put it over the x. What is it? It's 0. What's the tangent at pi over 4? Take the y value, put it over the x. 1. Good, Brian. Guys, what's the tangent at 3 pi over 4? Negative 1. What's the tangent at 5 pi over 4? Positive 1, because a negative divided by a negative is a positive. What's the tangent at 7 pi over 4? Negative 1. Do you see how they're all the same? If it's over 3, it's the same ordered pair all the way around. If it's over 4, it's the same ordered pair all the way around. The only thing that changes is the signs. So the only two unit circle angles that could give you a tangent of root 3 over 3 is either something that's over 3 or something that's over 6. And this is where you guys, if you don't memorize it, no big deal. Just work it out. This is my y value. This is my x. Take your y value, square root of 3 over 2. And if I divide it by 1/2, it's the same as multiplying it by 2 over 1, correct? Do you guys agree with me? So the tangent here would be the square root of 3. So at any ordered pair all around the unit circle that has 3 as a denominator, your tangent is going to be the square root of 3. It just depends on what quadrant it's in, is if it's positive or negative. So let's look at this one. If I take my y value, 1/2, and I divide it by root 3 over 2, it's the same as multiplying by 2 over root 3. I get 1 over root 3, which gives me what? Square root of 3 over 3 for a tangent. So any ordered pair, any angle that's over 6, is going to give me what kind of a tangent? What's it going to be? Square root of 3 over 3, whether it's positive or negative. So if you know the first quadrant tangents, you don't even have to think anymore. If you don't, no big deal. Just put the y over the x. So in this case, we have 4 answers. I want all the positive, negative root 3 over 3. So it's going to be which ones? 5 pi over 6. 7 pi over 6. Pi over 6 and 11 pi over 6. Good. If you have tangent or cotangent. If you have 1 over, what do? You just flip it. So think about the first quadrant. If I said to you, where is the cosine in the first quadrant? Where is the cosine 1/2? Pi over 3. If I said to you in the first quadrant, where is the cosecant 2? Cosecant goes with what? What does cosecant go with? Pi over 6, right? Why is it pi over 6? Because cosecant goes with sine. Sine is the y value. If the y value is 1/2, what's the reciprocal? 2. 2 over 1. You flip it. You guys have to remember those. That's why at the day I was out, I did that 4.4 review, and you guys are sending me messages like, I don't remember our 4.4. Okay, we can't do something and then you just never think of it again. It's coming back. So you guys have to know those ratios. You need to know what's the reciprocal of what. We're going to skip 4. It's very easy. I'll just come back to it tomorrow. I want to do these next 2. All right, we get to something like this and you guys are like, seriously? I thought this was easy. What is this word right here? Factoring. What did I tell you is never going away? Factoring. Okay, we need to think how? Algebraically. So this, if I wrote this, 2x squared minus x minus 1 equals 0. Every single person in here, excuse me, could solve this. You say a times c, yeah? Negative 2. What are the factors of negative 2 that multiply to give me negative 2, but add to give me negative 1? So x minus 2, x plus 1. Perfect. My a term is not 1, so what do I do with the a term? I divide it, right? So this becomes x minus 1, and this becomes 2x plus 1 equals 0. And then we solve, so we get x equals 1, and x equals negative 1/2. Everybody with me? All right, this is the exact same problem. Instead of x in the front of each of my parentheses, what am I going to put? Sine. Perfect. I multiply a times c. It's negative 2. What are the factors of negative 2 that multiply to give me negative 2 and add to give me negative 1? minus 2 plus 1. You guys agree? No problem. Do you guys agree? Okay, so what do I do with my a term since it's not 1? I divide. Perfect. So this becomes sine x minus 1. And this becomes 2 sine x plus 1. Questions? The only thing that has changed from a basic algebra factoring problem is instead of using x, God bless you, we put the trig function. So what do I do now with each parenthesis?
You equal it to 0.
Set it equal to 0. So sine x minus 1 equals 0. 2 sine x plus 1 equals 0. So here I get sine x equals what? 1. And here I get sine x equals negative 1/2. You guys agree? Okay. That's not what the answer is, though. I want to know which angles have a sine of positive 1 and a sine of negative 1/2. Well, sine is what value? Y values. So in this case, we're going to have a couple different answers. That's fine. So where, guys, on the unit circle is your y value positive 1? Pi over 2. Perfect. So this one is x equals pi over 2. The second solution is where are the y values negative 1/2? 7 pi over 6 and 11 pi over 6. Perfect. So x equals 7 pi over 6 and 11 pi over 6. Perfect. Very good.
And all of these are correct? We don't have to do checks or anything?
Nope. As long as your algebra's right, you're good. All right, look at the next one.
Can you go back?
Sure. All right. Can I do one more? Let me just finish this one and then we're done. I'm going to finish the other ones tomorrow. Yep. All right, how does this one look to you guys? What do you notice? Different trig functions. Is one thing squared and one thing not? Right? So this is probably a factoring problem. If I said to you guys, to factor this, you would tell me you couldn't, right? Because it's not the same terms. The last one had the same trig function, sine squared and sine. Well, when you have a quadratic, this is a quadratic because the highest exponent is 2. When you don't have the trig functions the same, listen to me, guys. You are always going to convert to the middle. Always, always, always. You're always going to convert to the middle trig function. What happens if it's not in the middle? You have to rearrange it. You always want to convert to the trig function that has an exponent of 1. What is the exponent on sine squared? 2. What is the exponent on cosine? First power. You're always going to convert, and you will have your, you will have your fundamental identities. This will always work out. So you have this problem. It says 2 sine squared x plus 3 cosine x minus 3 equals 0. You're going to factor. This is a factoring problem because you have something squared. You have a trig function squared and then one that's not. I just told you, you're always going to convert to the one that is to the first power. So what I'm going to do is I'm going to rewrite sine squared in terms of what trig function? Cosine. What's another way I could write sine squared, guys? Using your Pythagorean identities. 1 minus what? Cosine. Yep. Sine squared is the same as 1 minus cosine. You're always going to convert to that one that is to the first power. And now this is just a basic factoring problem. Basic algebra. What do I do with that 2? I'm going to distribute the 2. So it goes here and here. So I have 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Can we combine like terms? Yeah. A positive 2 and a negative 3 gives me what? So I have Good. Negative 2 cosine squared x. That negative didn't go anywhere yet. 3 cosine x minus 1 equals 0. Now, one thing before we factor it. Do we like to factor when we lead with a negative?
No.
So what should we do with the whole equation? Divide or multiply by negative 1. So this becomes 2 cosine squared x minus 3 cosine x plus 1 equals 0. Do you now have the same trig functions? 1 squared, 1 to the first power. So we just factor it. What's going to go in the front of each of my parentheses? What's the trig function that's going to go in the front? Cosine. So 2 times 1. What are the factors of positive 2 that multiply to give me 2 but add to give me a negative 3? Minus 2 minus 1. Good. My a term is not 1, so what do? Divide both by 2. So I'm left with cosine x minus 1 equals 0. And 2 cosine x minus 1 equals 0. You guys see that I moved the 2 here? One more step. So cosine x equals 1. This is cosine x equals 1/2. You guys with me? Move the 1 over, positive 1, then divide by 2. So I don't really care, not that I don't care, but I'm not looking for the cosine of these angles. I want to know what angle we're actually talking about. So where in the unit circle am I going to be looking? X values, perfect. Where x values are a positive 1 and where x value is positive 1/2. So we go to our unit circle. Where is the x value positive 1? At 0. What's another way you can write 0? Yep, x equals 0 or 2 pi. I don't care which one. And then where are my x values? Positive 1/2. X value pi, yep, pi over 3. And where else? 5 pi over 3. Perfect. So pi over 3 and 5 pi over 3. Good. So when we're talking about solving an equation, guys, if you want to, at the very first step, if you want to replace the trig function and you want to put, just take the sign, the cosine, you want to take it out. You're like, I don't like looking at that trig function. I want to use just a variable. You can do that. And then you can see how you solve it algebraically. You can go now, bud. But you are absolutely, you're taking your algebra skills and you're solving equations. And then we're taking what we learned in 4.4 and 4.2 about our x is my cosine value, the y is the sine, what are the trig ratios of y over x, x over y, that sort of a thing. And you're going to use that information with how you solved to find your answer on the unit circle. That make sense? Okay, so you have a WebAssign PDF. It's just the PDF. You do not have to answer in WebAssign. You can probably do half of it now or start it. I'm giving you this opportunity so you guys can try it, and if you have questions, I can answer them. Tomorrow, I'll finish the last 4 examples, and then on Friday, you guys can just start working. You can just start working on the test review. Sound good? Okay, good job.